Okay, forces and acceleration follow-up, page 3 here. We're looking at kinetic friction now because we're sliding. So what we're saying is that we're moving to the right and down at constant speed. So A is 0 for both. I have a coefficient of kinetic friction between the block and the table of mu sub k. So we're trying to find mu sub k, assuming we know the masses and we know the fact that this thing is moving at constant velocity. So F nets for the box here on the table, it's being pushed up by the table, it's being pulled down by the earth. It's being pulled to the right by the tension in the rope. It's being pulled to the left by static friction, which is always mu sub k times n. And just mu sub k by itself isn't a force. And this is balanced because the velocity is constant. Alright, so now the forces in the rope, tension, same tension there, and an mg down, which is smaller than this mg, so everything's in the right proportion. I'm going to again call right and up positive here, and down positive, because this right, if it were to accelerate to the right, then this would accelerate down. I want to keep those directions consistent, even though I don't have any acceleration here. So F net, cart, in the x, t to the right, mu sub k times n to the left, equals 0 because it's balanced. The forces are balanced because the velocity is constant. Just because it's not at rest doesn't mean the forces are unbalanced. In the y dimension, normal force pushing up, mg pulling down. For the hanging mass, we have mg pulling down and t pulling up. And those forces are also balanced, again, because it's constant velocity, even though it's not 0 constant velocity. So mg is the t. I can sub that in. And looks like n is equal to mg in this case. Bring that over to the other side and cancel the g's. Hey, this is looking familiar. So the minimum coefficient of kinetic friction is little m over big M. And we have the same sort of functional dependencies we did before. So if the coefficient of static friction was as big as it needed to be in the last one, this would never happen. And if we were to give it a little nudge or something to get it moving, then the coefficient of kinetic friction would be smaller than that. And so this friction force wouldn't be big enough and it would accelerate downward. If the coefficient of kinetic friction were this big, were big enough to let it slide at constant velocity, that means that the static friction coefficient would be bigger, which means that we'd have to give it a nudge to get it started. So there's some definite consequences of the coefficient of kinetic friction being always smaller than the coefficient of static friction.